Can we begin the live streaming, Gigi?
Yes, sir. Welcome to NTW2025 Site Reliability Engineering Foundation class. I'm happy to welcome you today. We're excited to have you join us for this insightful session. I would now like to introduce to you our trainer, Mr. Ramesh Alwan, who will be leading today's class. Mr. Ramesh, over to you.
Thank you, Gigi, and good morning and welcome. Good afternoon and welcome everyone. So, thanks for joining us today. I'm sure you will find this session very insightful, and don't hesitate to ask questions if you have any. You can stop me and ask questions, or you can choose to ask questions right at the end of the session. This session should last anywhere between 75 to 90 minutes approximately, depending upon how interactive you are, right? So please feel free to interact and keep this session as interactive as possible. Let me begin. I've got a set of slides that I'm going to beam, and then we will begin from there. Let me share my screen. Gigi, can you see my screen?
No, sir. You can share it again.
Now?
Yes,
Okay.
sir.
I hope all of you can see my screen.
Yes, sir. It's visible, sir.
Very nice. Thank you and welcome. It's going to be a nice, quick, short session, not very long. And I promise to keep this as interesting as possible. All right, so this is the agenda we have. We will start off with a quick introduction about myself. We'll follow it up with topics. What is site reliability? Why is it needed? What is the comparison between site reliability engineering, operation versus development, the core principles, error budgets, what is SLI, SLO, SLA, what do you mean by TOIL, collaborative culture, change management in SRE, how does SRE really work with change management, observability stack, interesting concept, right? Monitoring and alerts are going away. Observability is taking over. We would love to see how observability is taking over. What is the benefit of observability? Then automated alerting and runbooks, chaos engineering, implementing SRE in your organization. Then finally, measuring success. This is an overview session. As I said, run for about 75 to 90 minutes. I finally have a Q&A and a wrap-up session in case if there are any questions. Please feel free to ask. In between, if you have questions, you can still stop me and ask. I've got some activities in case if you guys are interested, we can do that. Otherwise, Gigi will share the activities with you guys later on. So with that said, without much ado, let me move on. My name is Ramesh Alwan. I come with about 43 years of experience. I'm a retired Indian Air Force veteran. I'm based out of Chennai in India. I lived in Malaysia for 2 years, 2.5 years, 2015 to 2017. I was based out of the Cyber JF campus for IBM. I used to work for IBM those days. I was managing the IBM Global Delivery Center in Cyber JF. So my connection with Malaysia is very strong. And I've loved Malaysia as a country as always, right? And I retired from active work in 2022. Since then, I've been training. I've so far trained about 4,500 candidates across different streams. As you can see, I'm a certified DevOps Foundation and Leader Trainer. I'm a certified DevSecOps Foundation and Practitioner Trainer. I'm a certified Site Reliability Foundation and Practitioner Trainer. I also train on observability and AI Ops. And I'm also a trainer in the business relationship management area. I hold a master's degree in computer science and applications, ITIL certified before. I also train in ESG, environment, social governance. I'm a certified consultant. I work for companies in terms of providing them consulting around the sustainability reporting area. So that's a quick rundown. Long career. I started off with the Indian Air Force for 10 years, and then I moved on to Corporate career, I used to work for a franchisee of Wipro, then moved to Citibank, from Citibank to GE, from GE to PwC, PwC to IBM, and then I retired. So about 4 or 5 companies. I spent about 30 years in the corporate world, 34, 35 years in the corporate world, and the rest of it in the Air Force. Fundamentally, I'm a mechanical engineer, but I understand IT very well because I've been in IT for about 35 plus years now. So with that, we will move on. I have a disclaimer here as we proceed through the course of this session. There will be quite a few tools that I will refer to, right? The tools that you can use. This necessarily does not mean that I endorse these tools or recommend any of these tools. Tools are a choice of the technical consultants. So for me, my preferential tools may be different from what any of you in this call would love to. So generally, it is more from a reference standpoint where we come back and talk about some tools that we use during the course of our consulting work that we do for customers. So every environment is different, and each environment will require a different set of tools with the different parameters that needs to be configured. With that said, that's the disclaimer that I wanted to put up front, saying that I don't want people to be thinking that this was a tool recommended by the trainer. So you can, I'm not saying that you should not use that, but if you think that will be useful for your organization, for your enterprise, I think you should go ahead and use that. Let's look at what is site reliability. Site reliability engineering is a combination of operations plus software plus a collaborative culture. The term collaborative culture stems from DevOps. DevOps is a philosophy. A lot of people think DevOps is a tool. No, DevOps is a philosophy. And the best implementation version of DevOps is site reliability engineering. The core focus of DevOps is more around developing software, releasing new features. There is a concept called velocity of features in DevOps, which means at what speed do you go back and release new features to your market, to your customers. And a good example, and this is something that I've heard about. I have not worked in Amazon, but I believe Amazon does a release every 12 seconds. That's about 5 releases in a minute, 300 releases in an hour. Is it true? I really don't know, but I've read about it. I've heard about it. And I'm sure they're more than capable of doing that. Their systems are so well automated that they can actually do so many releases. Now, remember, guys, a release could be as minuscule, as small as changing the name of a field, in an application, or changing the color of the field, changing the font of the characters, or introducing a new field, or deleting an existing field. It can be anything that causes a change in the application. So that's what is called a release. Now, any change will immediately, it means that you'll have to put up a build. The build will have to be tested, and then once tested, it gets released as an enhanced feature or a version. Now, to do that, you have to make sure that your development team works hand in hand with the operations team, right? There is a culture of collaboration that needs to exist between a development team and operations team. Now, the best question that I've ever had is somebody asked me, Ramesh, do you mean to say that the operations team is the same as the SRE team? Possibly, yes. I would say 50-50. It's an yes and no, because an SRE typically comes from the operations team, but also comes with a lot of knowledge around coding. Coding here, I basically mean that, building software applications. So a site reliability is a combination of operations, people knowing software, and who knows how to collaborate with different parts of the organization. So site reliability engineering promotes this culture across using the DevOps philosophy. The second bullet talks about ensuring services are reliable, resilient, and scalable. Site reliability engineering makes sure that your servers, your applications, your services, your products, anything that you offer to your client is reliable. It is available. Resilient meaning it can work against failures, or when something fails, it will gradually shut down, and there's always a failover that can immediately take over. Scalable means that as the volume of transaction, number of transactions, number of users go up, the infrastructure and application can automatically scale up to accommodate the increase in the number of people or transactions that are increasing. So site reliability also talks about reliability, which is, services are reliable, consistently reliable, they are available, they are resilient, acts against failures, and scalable. They can scale on demand. And lastly, SRE is equal to operations with a software engineering mindset. Site reliability engineers are basically operations people, but with the mindset of a software engineer. Now, if you, the best question, the question that somebody might have is, Ramesh, what do you mean by a software engineer's mindset? Very simple. Software engineer always thinks about something called an SDLC, Software Development Lifecycle, which starts off with requirement gathering, design, which is high level and low level designing, and then converting the design into a bill of materials, then start coding. After coding, do unit tests, then release a build, do an integration testing, then put it in a CI/CD pipeline, deliver it to put it in staging, do testing, release it to production, uh, deploy it in production, and then release it for users to use. So that's a typical software development life cycle that a software engineer thinks through every time. So an operations engineer, a site reliability engineer, is somebody from an operations with this software engineer's mindset that typically talks about how do we think in terms of thinking through the software development lifecycle for operations. So that's what site reliability engineering is all about. Why do you need this? But remember 10, 15, 12, 15, 20 years back, we all had our own server rooms in our office. We had 5 or 10 servers running. And then your boss asked you to put up one more additional server. You went through the grinding process of, taking 3 quotations from 3 different suppliers. And then that goes to your procurement. The procurement decides the vendor based on price, deliverable, all of that. And then one of those 3 vendor gets selected, shortlisted, the purchase order gets released. There's a delivery timeline of 8 to 10 weeks or 12 weeks sometimes. And once it is delivered, it has to be unpacked, then racked, stacked, installed, mounted, installed with operating system, patching, connecting to network, installing applications, database. Look at all the activities that you do. The whole concept of, putting up a server, those days, one additional server meant you probably waited 12 weeks for the server to come and another 1.5 weeks for the server to go live. But today with cloud, you need a server, it can just be brought up in maybe a minute or 2 minutes. You just have to go to cloud and place an order. And there are ways of placing an order. You use infrastructure as a code at the back end, and then you just do a few mouse clicks, make a payment using a credit card, click submit, and then your server is up and running in 2 minutes. Now, the proliferation of cloud over the last decade or so has given rise to this complexity where, people have gone ahead bringing up servers at will and fancy. You needed 10, you could probably bring up 10 servers. So the complexity of systems in terms of the number of servers that can be brought up at a given point in time, the distributedness of these, right? So let's say when you order a server from Kuala Lumpur, when you go to AWS, maybe AWS data center in KL gives you one server. When you also add to the configuration that you need a failover server, that could either go over to Singapore or to Japan or to Australia or to the UK, depending upon which region you select. So your server with your data, with all the confidentiality, will probably reside in a different data center in a different country, just to make sure that it provides you with adequate disaster recovery and business continuity capability. So such is the distributedness of the system today. To manage such systems in such wide distributed array, it is going to be impossible for physical human beings to sit and monitor and manage all these servers. You need the concept of SRE, where automation is the key, and we are going to look at all of what are the features of SRE. What are the key concepts that are getting talked about in SRE? You need the SRE principles to be able to manage such complex distributed systems. Faster delivery pressures. And I told you, Amazon does a release every 12 seconds. Every company wants to do more releases in the market. Gone are the days when you did one release a year. Today, people are talking about one release a day, or maybe 2 releases a day, or 1 release a week, there's a lot of pressure in the software development team for them to release new features every now and then. with the market feedback coming in, every time they come back and code new features that gets then released to the market. So this kind of release pressure means that as they build and test and are ready for release, your underlying infrastructure that is being managed by the site reliability engineer must be capable of supporting these releases. Right? Your underlying infrastructure environment must be stable. If it is not stable, it'll just crash. It'll bring down the whole application. So the delivery pressure also can be handled only when you have a very good SRE implemented across the organization. And the third point is rising customer expectations for service stability. Every customer wants his service to be stable. A good example, guys. I'm sure all of us watch Netflix, right, at home, or maybe Amazon Prime, or whatever platforms are available in Malaysia today, right? So let's say you're watching a nice Tom Cruise movie, and then suddenly if there is an outage, it kind of kills the experience that you've had watching it, right? So you would say, oh, do they have backup? Why does it take so long? Why does it fail so often? So the expectation from the customer in terms of how stable they expect the services to be has gone up with all the cloud proliferation, application and automation and all of that. So to meet that, again, you will need the principles of SRE to manage that. And lastly, operations teams overall. Toil is nothing but manual work. See, prior to automation really stepping in about 10, 12 years back, a lot of work was being done manually by engineers, system administrators and engineers, right? And they were so overwhelmed with all the work that they had to do. Right? Their task that it was an unending list that these engineers sat through day after day, regardless whether it was a Friday or a Saturday, and worked through to make sure that their bucket is always empty. But sadly, the bucket never got emptied because by the time they finished 10, 20 more would get added. So such was the pattern in which these people were doing toil or manual work. It became almost impossible for them to meet the expectations of the customer. Again, SRE stepped in as an implementation framework of DevOps, which helped bring in the concept of automation broadly into operations that could then take care of all this toil or the manual work that they were doing. And we're going to see how automation helps toil very soon in the next couple of slides. So let's look at the difference between SRE versus operation versus development. On the left side, the first column, which is this, you will see the primary role, the activity, the skill set, and release cadence. Then you got a comparison between operations, SRE, and development against each of those. So primary role for operations, it is to manage production. SRE is part of operations. They move from operations, but their primary role is to automate and enable. Whatever was being done manually, they will automate and enable it. Operations guys generally are not very adept at automating and enabling, right? So, and then you got development, which is creating features. Like I told you, they create new features that gets released to the market. From an activity standpoint, operations is very manual, very reactive. There is no proactiveness or predictiveness. But in SRE, it is very proactive, automated. To an extent, we can also call them to be predictive, depending upon if they've induced artificial intelligence or AI ops for IT operations, then they can also become predictive. From a development standpoint, developers' job is basically design and build. Design, build, and implement. Right? They don't go beyond the build and implement. Then from a skill set standpoint, operations is general IT. They're not specialists. SRE is general IT plus coding. But SRE, apart from the general IT skill, they also need to know coding. And for development, you need to know coding and must have a solid understanding of what kind of architecture are you going to go and code. And lastly, release cadence in operations is very, very controlled, which means that once a month or once in 2 months, once in 3 months. In SRE in development, it is rapid. It could be once a week or once in 3 days or twice a week or thrice a week. It all depends on the organizational priority. If the organization needs more releases a week, so be it. And it becomes the job of an SRE and development team to work hand in hand and make sure that the organization is subject to summit. We then move on to SRE core principles, error budgets. Error budget is equal to tolerable failure versus 100% perfect. Now SRE talks about some key concepts which you look at. Error budget policy. We'll talk about SLI, SLO, SLA. We'll talk about automation. So first we'll start off with error budget, right? Error budget is nothing but, let's say if in a month you've got 30 working days, and your application or infrastructure works 24 hours a day. So 30 days into 24 hours per day makes it 720 hours. Let's assume you are promising your customer that your application, service, and server will be up and running for 29 days in a month, which means you'll have a downtime of 1 day. The 1 day downtime is called the error budget. So basically, if you come back and look at it, the definition of error budget will say that the amount of time for which a service or a server or an application is authorized to go down. When I say authorized, agreed with the customer. There are ways of calculating that comes as part of the training. It's a 1 hour exercise by itself, where you come back and look at how do you calculate SLA, SLO? How do you calculate SLA? It's a vast topic by itself. It runs for a few hours. In the class, it takes about 1.5 hours to 2 hours to just clear off SLA and SLO, right? So error budget is, if you have to really calculate 100 minus SLA or SLO becomes your error budget. That's how you go back and calculate error budget. Align incentives for innovation with stability. You see, I put an arrow, right? When you say incentives for innovation with stability, most customers want stable infrastructure, stable services, stable applications, right? And they want you to constantly innovate, which means that can you bring in new things? 20 years back, we just had theaters in which we went and saw movies. 20 years down the line, we've got multiplexes, we've got Inoxes, right? We've got Dolby, Atmos, Dolby 5.8, 5.9, stereo effect. The experience of going and watching a movie in an Inox is completely different, right? So all of this was possible from an innovation standpoint. Servers in a data center within your office versus servers on the cloud, AWS cloud, Google cloud, Microsoft Azure cloud, right? Televisions without remote, televisions with remote, air conditioners with remote, without remote, no air conditioners 40, 50, 60, 70 years back. 100 years back, airplanes were not there until Wright brothers invented it. So everything comes out of innovation, right? So in the organization, if the IT team is innovating without compromising the stability, SRE preaches or advises the practice of rewarding those innovations with stability, which means that if a team, the SRE team is innovating or the operations team is innovating a new idea that can increase the efficiency of the team, that can increase the availability, reliability of the service, infrastructure, and application, then they must be rewarded either in the form of a reward or in the form of a promotion or a salary increase, whatever. There are no specific recommendation as to what that incentive should be. But the point of the matter is that they must be incentivized so that looking at that, more people will come up with more innovative ideas. Reducing cost pressure, reducing pressure for 100% up at all costs, right? So one of the things that error budget does is the moment you declare an error budget, the customer knows that his server or service will not be available 100% of the time. You told him 1 day in a month, I will be down. That's what you signed for, that's SLA. So which means there is no pressure on you to meet 100%. And lastly, providing a way to gauge when it is okay to take a risk. Error budget tells you that, oh, there is 1 more hour of downtime left this month. We are already on the 27th. We just got 3 days to go. The infrastructure is stable, application is stable. I want to probably go test another new feature, and I'm going to need some downtime. Since I've got 1 hour error budget left still, I can use that 1 hour error budget to go back and test my new feature. So that's what they mean by it is okay to take a risk. SLI, SLO, SLA explained. SLI measures service health. SLI is nothing but anything that you measure. It kind of tells you what is the current situation. What is your current reading? What is your current status? What is your current health? Right? So anything that you monitor and measure, that becomes your SLI. For instance, you take up a thermometer and measure your body temperature. So what are you measuring? You're measuring your body temperature. Body temperature becomes the SLI. The measurement, the temperature will tell you your body temperature now is 98.4 degrees Fahrenheit. So that becomes the reading of that SLI. At that point in time, let's say by my clock, it is about 12 in the afternoon. It should be about 2:30 or 2:31 in the afternoon in Malaysia. So 2:31, somebody's body temperature is 98.6. And then at 2:05 or 2:10, it could be 98 or 99. So remember, SLI is something that you monitor, but the readings of the SLI will never be constant. It will keep varying at different points in time. So SLI has a point in time reading that might change over a period of time. So it's something that you monitor to measure the performance of that component, of that application, of that service. SLO is basically a very internal, inner-oriented target that is set for the organization. For instance, you say you're building a new application. The first question is, can you tell me how long the application will be available? You will say 99% or 99.3%. That becomes an SLO. SLA is an enhanced version of SLO. The difference is SLO is very internally focused. SLA is something that you go back and sign with your customer. So in our example where I said out of the 30 days, 1 day is downtime, 29 days. Let's assume 29 days for the SLO. Then with your customer, when you sign up a agreement, which is service level agreement, which is called the SLA, the recommended way is not to sign for 29 days. Don't go back and say my service will be available for 29 days because you will have no room for errors. So the SLA should always be slightly lower than the SLO. It's a promise to the customer saying that, okay, my application, service, and infrastructure will be up and running for 28.5 days. You've built a buffer of half a day because in case you want some additional testing to be done, you don't have to go back to the customer asking them specific permission to go back and test or to go back and bring down the services. So that's SLA. I repeat, SLI is something that you monitor. It gives you a point in time reading. SLO is a service level objective, which gets measured. It's very, very internal to a specific service or a product or an offering. SLA is very similar to SLO. The only difference is SLO is very internally focused, which means that the target that you set as SLO is for your own team. But SLA is something that you commit to customer through a contracted form by signing a contracted form saying that, oh, I'm signing up for my application services to be available for 28 days in a month or 99.5% of the time or a latency of less than 300 milliseconds. It could be anything. That's what is called an SLA. Let me take a pause here. Are there any questions so far, guys? No questions? Can I move on? Okay, toil reduction. Toil is nothing but manual, repetitive, interrupt demanding tasks. Let me pick some examples. Anything that you do manually. I don't know what is the average age of the group on this call, but anybody, any youngster who's about 25, 26, 27, 20 years back when you were probably 2 or 3 years old, or 22 years back when you're just about a year, I'm sure most of the countries in the world had television sets that did not have a remote. So if you really wanted to go change the channel, you had to get up from your couch or sofa, walk up to the television, change the channel, and come back. To increase the volume, you had to walk up to the television set, increase the volume, or decrease the volume, come back and set. Right? That was a very manual task. Then the remotes came in where people sat in their couch and started doing that. Then they realized that the remote was getting lost. Android came with a program where you can use your mobile as a remote control for your television set. Our grandfathers, our great-grandfathers traveled by bicycle to the fields, to the factories, but we all travel by car. Cycle was very manual. Car is more automated. People travel by bikes. I'm sure in Malaysia, it resonates very nicely where even now in provinces, or villages, you will still find a lot of homes using stone to grind. You know, you come back to cities, you'll talk about mixer grinders or blenders that people use. I'm not saying villages don't have it, they do have, but some villages, the remote corners still use traditional methodology of cooking food, right? So anything that eliminates labor will get into automation mode. So toil is basically manual work, and it is very important for us to make sure that toil is reduced from the cycle. Now let's come back to the IT example. You had earlier you wanted to back up, you connected a backup drive, you had a backup specialist go and select which folders had to be backed up. You will start the backup, you'll monitor the backup, you will stop the backup when it is all done. Today everything is automated, right? You had for every time patches had to be installed, somebody had to download, patches had to be put on a test bench, you tested them, then you install them on the server. Before that, you look at compatibility for applications running on the server. A lot of manual tasks were done. Today, everything is automated, right? You have a patching server that connects to the internet automatically, downloads the patches, there it runs it on test benches, finds out whether it's compatible with applications running on the server, then goes back and so everything is kind of automated. So anything that is manual, repetitive, every day you download 10 files from a server for doing analytics. Instead of you doing that, you can get an automation to do that. That's repetitive. Interrupt demanding task. You're seriously uh, preparing a project plan for implementing an ERP for one of your customers. Suddenly, somebody comes and tells you, "Oh, the server went down." You went and fixed it and came back. Another half an hour later, somebody else walked up and say, "Hey, Ramesh, the application is not working. Again have to go." So interrupt demanding tasks basically meaning that when you're halfway through the work, there is a lot of interruption that seeks your attention to go fix a problem. So in those situations again, those are areas where you look at toil as one of those key adders that brings down the efficiency of the system. The last point is SREs aim for maximum automation. The aim of SREs is, like I was telling you, right? In this slide, we just saw SRE is all about automation enabling. What they basically do is they pick up manual tasks and see how much can they automate so that they can make the life of the people working on the floor much easier. Collaborative culture. Operations plus developments plus security. So collaborative culture basically means ops plus development plus security. So in olden days, when you built an application, right, you probably finished building it, testing it, then you called the security guys to come back and check. They'll give you a list of 20 findings. And then you go back to your boss and tell them, "Boss, we finished everything. Security is now coming up with a list." This is too bad. They're delaying the release. But the fact of the matter is that it is not the security's problem. You did not involve them upfront. You brought them in at a very, very late stage in the life cycle, which means that you're about to do a release. That's when you're asking security to take a look. And they come back with a set of findings. It is so important for us to go back and fix them rather than going and complaining to our bosses that security is actually delaying the whole release. Now, how can that happen? There's a concept called shift left in SRE, which means that from right to left, if you can see my hand, extreme right to extreme left. Extreme right is operations, where you manage, monitor, and manage the server. Extreme left is where you create designs for the application service. So what you need to do is you have to bring in security early in the life cycle at a design phase where security can give you a lot of inputs, insights around how should you build a safe application. What are the do's and don'ts when you build an application? Can you use open source or not? What libraries should you use? What you should not use? What you should stay away from, right? So there are a lot of those important aspects that security can actually bring in at a design phase so that you don't have to rework. Rework basically means demoralized employees, more money flowing out of the uh, uh, suitcase. So all of that becomes a big problem. So operations plus development plus security basically means that SRE plus the development team, which is the DevOps team or the development team, should go hand in hand with security right from day one or day two, so that security doesn't spring a surprise on you guys when you're ready to declare go live. Collaborative incident reviews. Now, generally, incident reviews, you will find that nobody comes up, excepting the incident manager. He will run behind 10 people trying to request them, can you please join the incident review meeting? Nobody wants to come, right? But now that is not really a very healthy sign, because if you don't have a developer, if you don't have a security guy, if you don't have a database guy, if you don't have an architect guy in incident reviews, it is going to be chaotic, because the ops guys can only think or talk about so many things. Beyond that, it becomes the developer's job to understand if it is a code issue, if it is a configuration issue. All of that gets determined by the developer, right? So it is so important that the SRE and the operations team, when they work on incident reviews, the application team, the middleware team, in fact, there must be representatives of the leadership team also on the incident reviews, so that all of them together can all of them can review together and give one uniform input that can then be implemented. Collaborative incident reviews basically means that bringing together development, operations, and the security together in one place so that they can review the application commonly. The third one is blameless postmortems. So every time an incident happens, I'm sure all of you would have heard about root cause analysis. That gets done about 3 days or 3.5 days, depending upon what the company's agreement is with their client, right? Now, postmortems are nothing but these kind of root cause analysis that you basically do. Now, blameless postmortem means that when you do a root cause analysis of a problem, don't start blaming people, saying that, oh, this was Akila's problem, this is Magendra's problem, this is Padma's problem, this is Yamini's problem. So don't get into a personification mode when you do a postmortem. So blameless postmortem basically propagates the culture where you understand what happened, why it happened, and not really pinpoint issues on people. That's not going to help us move forward. That's blameless postmortem. You don't blame people. Lastly, shared responsibilities and incentives. Now, every time when you talk about shared responsibilities and incentives, let's assume it's a Black Friday season or the Thanksgiving season. The developers are really rolling out new feature after new feature. They are completely engrossed. There's more work to do, but they don't have the time. Now, operations guys, the SRE guys, are guys who come with limited exposure on development or coding. Now, they can always jump in to help the developers, which means that they can help build a module or a sub-module for a developer. Developer can then take it, test it, and if everything is working, he'll publish it along with his build that he's going to put in the Git or any of the repositories. And then when a second incident could be during Thanksgiving itself, all applications rolled out, there are 100,000 customers who are logging in and the servers are fluctuating very frequently. Ops is completely involved in all that. And let's assume for some strange reason, the ops team does not have the bandwidth, they don't have adequate people to manage additional outages. It is expected development can come in and start sharing responsibilities. The question though is, does development team know how to manage an infrastructure or a server? The answer is no. That's how they learn it. They'll do it under supervision. Similarly, when an ops guy wants to go help the development team with some bit of coding, the code may not always be right, but at least they will try and build the idea, build the protocol that the development team had committed back to the customer. So shared responsibility basically means that SRE is working on issues related to development and development working on issues related to SRE. That's what is called shared responsibilities and incentives. Change management in SRE. Implementing safe deployment practices, blue, green, canary. I've given you a picture for everything. I'll quickly run through them. Automating rollout and rollback, continuous delivery with control mechanisms. Now, implementing safe deployment practice, blue, green, canary. You can look at the pictures. Blue, green is nothing but this server called V1 is running application V1.1, right? And then the software developer said that the market needed new features. We built it. We're going to release 1.2. So what you do is, instead of getting that 1.2 onto this server, then stopping users from accessing it, then releasing, testing it, then releasing it, you can actually put up a extra server where you actually bring in the new version of the software that you want to roll out, test it completely. This is a prod server like the green one here, right? Test it completely. Once you're convinced that the application runs without a problem, all you have to do is just divert the traffic from V1 to V2. All you're doing is that whatever traffic is going here, is just diverting the traffic to a different server. This is what is called blue-green deployment, where you are very, very sensitive about the amount of downtime that is required whenever you do new releases, right? The customer is comfortable with this 1-2 hours that you spend on doing a blue-green, so that's what you should be doing. Similarly, canary deployments are nothing but deploying in small quantum for a small handful of users. This same build that you put on V2, if it contains 5 smaller modules, you can pick one module for which you can create a video. And then what you do is you basically come back and look at, play that video to a set of users and tell them, do you guys think you can test it? You give it to them, you roll out the feature and select only that group of users who are confirmed to you that they can do the testing for you, release it to them, they can test and give feedback. Now, what this canary deployment does is it makes sure that when you do big bang changes, large changes, and if it has an impact, the whole system could come crashing. But when you do canary deployments, small features to a handful of users, if it doesn't work, you can always roll back. Rollback is the last one. Rolling upgrade, we'll come to that. So you can always roll back to the previous version so that the system can continue running. So canary deployments are basically smaller size of deployments that gets done at different points in time. Rolling upgrade is nothing but you can run 2 different versions on your server, n and n-1, right? And let's say if n is the latest version, n-1 is the previous version, you divert your traffic to n-1, and if some of them starts complaining, you look at the percentage. Let's say you have a agreed percentage of not more than 5% of users will be impacted with the new version. Which means that if 100 users, 95 of them should be able to access the new features, and only 5 people at the best or at the worst will not have access to the system. So whenever you do V1, V2 on the same server, you maintain 2 different versions, you actually cut over on a day when everything seems to be working fine. And then if it runs without any problem, you have actually succeeded in moving to a newer system without experiencing a lot of downtime. Automating rollout rollback. So whenever, let's say you have moved all the 40 users onto the new version, and then 2 days later, you figure out that, teams are complaining that a lot of features are not working. They took about 2 days to test all the features. They say that a lot of features are not working, which means that you have to send that version back to the drawing table where they can find out what the issues are, fix them, and then roll out. And that means that you will have to have a version on which your customers can continue to connect, which becomes your existing version, which is what rolling upgrade. Since you can always roll back to the previous instance that was running in the server, to which your users or customers' users can connect and continue using the service. Observability stack. Now, there are different tools here. Prometheus is a monitoring tool. Generally, when you talk about observability, you talk about a lot of tools like Hager, that you see that's an open source tool. You could talk about ELK stack, Grafana, Loki, Datadog, Dynatrace, New Relic, Splunk. A lot of those, there are a lot of tools that are available today from an observability standpoint. The speciality of observability is that it gives you something called MELT, M-E-L-T. You look at MLT here, E is not present here. Deliberately, it is missing because you will get event also on the same server. So MELT basically means M stands for metric, E stands for events, L stands for logs, T stands for tracing. Metrics is something that you measure that tells you whether your service is meeting the expected value. That's metrics. Logs logbooks in which activities get returned, right? Every step in an activity that happens in a system, it gets returned in a log file. And that gets used in case tomorrow, if there's an issue, you want to find out what caused the issue, you can go back to a logbook and start looking at from the incident before maybe a day or a day and a half or 2 days, depending upon how long you want to go back. You wanted to see how did the system behave, what are the performance, did it go through a lean patch, was there an issue, was there an error, all of that you can check from the logbooks. So logs gives you the ability to pinpoint the root cause of a problem. That's why logs are important. Tracing, what you see in the right is tracing. This is from the screen of a e-commerce application, and this application is being monitored by a tool called Hager. You see that here, Jaeger. This is called Hager. It's an open source tool free of cost. And what it does, it provided these traces. Now let's look at it. Front end, checkout. The total transaction took about 1.01 seconds, and that everybody thought was very, very long. It should happen in less than one second, maybe less than half a second. But why did it take 1 second? So they went into the observability system. It produces these kind of traces that you see here. These traces gets provided. They look at the trace. Oh, front end is taking 979 milliseconds. Why? What under front end? So you then go back and look at something called, you break down the front end. Front end has got different components. You figured out that MS demo checkout. You are trying to look at a demo to see if the product can be seen in a demo. That was taking about 782.95 milliseconds. Now the checkout demo, why would it take 7? You would again wanted to see what within checkout demo is causing that issue. You just had to go back and look at, oh, the cart services took a long time. The cart services took about 240 milliseconds. Oh, why would the cart take 240 milliseconds? Again, you drop down. You go in and see that the get discounts was taking about 196 milliseconds. Now this becomes the root cause. So there was a problem. Some of the calls that the get discount part of the application was getting were not getting conveyed. As a result, the get discount part of the application was kind of staying in a hung state. So it had to, that service had to be restarted so that it could be done. Now, all of this, whatever I spoke now, can be diagnosed within maybe 30 seconds. In olden days, when you did not have traces, you had to call people, they have to look into the application, find out what went wrong. It might take an hour to even decipher. Today, you can just like that catch that. In 30 or 45 seconds or a minute, you get to know what is the root cause. That's what traces can do for you. Events are nothing but anything that happens between two activities is called an event. That's the simplest way of definition. So an event happening will be dependent upon, you can know if an event happened or not based on the metric, because the metric will tell you that the reading is not normal, right? When the reading is not normal, you go back to the log and see that the log told you that at this time there was this activity that was happening. You really wanted to know what caused that, then you go back to traces. So that's how you come back across Melt to go back and look at it. Now, observability as a concept is slowly replacing monitoring and alerting. Alerting still stays, monitoring still stays, but both of them are going to be part of observability. In the next 4 or 5 years that you see, monitoring and alerting will automatically fold into observability. Now, what can observability tools give you? It can also give you dashboards for real-time visibility. It can tell you how many times did this go down. It can tell you at what frequency did your processor utilization go up. At what rate did your disk IO read-write got filled up. So it can give you a lot of metrics that can give you insights into how do you want to go back and manage a system so that it does not go into a downtime mode, which means that your customers do not have a downtime. To that extent, you need to watch these dashboards. These dashboards could really give you a lot of insights as to how you want to manage a system. So observability is very key in making sure that your services, your systems and applications are not only available, but are also reliable. So availability and reliability are two different terms. Availability is being available for use. Now, is it in the best possible condition? No, it's not, right? Reliability means that it is available and it's also the best possible conditions because it is reliable. So that is the difference that we need to understand. So observability will help you make sure that your underlying service that you're offering for your customer is in an available state and a reliable state. That's what observability can do for you. Automated alerting and runbooks. Intelligent alerts without overwhelm. Runbooks to aid incident response. Collaborative incident timelines. Right? Intelligent alerts are nothing but, let's say if you're monitoring 10 aspects on your application and server, and then for all of them, you said that, okay, whenever the threshold is breached, send me an alert. So in a day, all 10 parameters that you're monitoring will generate, let's say, 10 alerts in a day. So 10 into 10 is about 100 alerts in a day. That's too much. The question is, you have to go back and ask, do I need an alert for all of this? Maybe not. I need alert only for critical services. Right? What are the critical services? Identify what the critical services are. While you monitor 10, you say generate alert only for these 3 critical services every hour. Right? For the remaining 7 services, generate alert once in 6 hours, which means I just need 1 or 2 alerts a day. That's all I want. So that is one way of creating intelligent alerts. Second, you could create an automation that could pick or consolidate alerts based on the category. You can go back and define a category where your alerts will actually give you adequate information about what is the potential cause of a downtime or non-availability. That's what is called intelligent alert. Runbooks to aid incident response. Runbooks are nothing but where you have a return down step-by-step process of how do you go back and fix an incident. Like when an incident happens, first incident manager should jump in, he should call the right resources, he must set up a call, and immediate communication should go to all the stakeholders. The tech team should continue to work fixing the issues. The guy who called for the meeting, the incident manager, will automatically keep communicating with the customer at 1 hour frequency. Everything is clearly written down. That's called your runbook. You must have a clean runbook to aid incident response. How quickly, how well do you respond is of utmost importance. A downtime has happened, and for an hour you have not told your customer. If the customer learns it from somebody else, he's going to really bash you. He'll say that, why do I need to know this from a different provider? You are my star provider. Why have you not told me that? Right? So the response part is so important. We cannot overlook that. So runbooks will also define how should you respond during an incident, how frequently should the response go, who should respond, how do you communicate. It talks about everything under the sky from an incident management standpoint. And lastly, collaborative incident timelines. Right? This basically means that you look at the development team, the security team, the infrastructure team, all of them come together and agree that, okay, this is the incident timeline they're looking at, because application guy may come back and say, oh, for me, it might take 45 minutes. Infra guy will say, oh, I'll take 60 minutes. Right? The security guy will say, I need 2 hours, 2 days. So you have to arrive at a common consensus among those 3 groups or 4 groups which are going to run the incident, agree on a number or a timeline that you want to publish to your client and go. So that's what is called collaborative incident timelines that comes to your aid. Chaos engineering, very interesting concept, right? Netflix turns out to be one of the best OTT platforms being watched by billions of people today. And about 15 years back, in fact, I remember my good old days in KL when I got an Amazon Prime stick to be inserted in my TV, through which I can actually, beam movies on my TV from my cell phone or iPad. Those days when I bought it, it came with a 3-month free subscription for a platform called iFlix. I don't know if it still exists. I've been out of Malaysia for about almost 6-7 years now, 7-8 years now, right? So at that time, I realized that iFlix was much better than Netflix. Netflix was probably not that very good. But what they did over a period of time, they established this practice called chaos engineering. Chaos is nothing but confusion. What they basically did was, chaos engineering is a discipline of experimenting on a software system in production in order to build confidence in this, which means that you broke the software deliberately. When it breaks, you saw what broke. Then you tried fixing it. You understood how to fix it. And then you automated so that in real time, when that incident happens, it'll automatically run the fix. That was step 1, being reactive. or proactive, right? The next stage, what he did was he infused or integrated AI ops engine to a system, and then it started predicting that the last time when such parameters were noticed, there was a downtime 1 day from then on. So today we are monitoring, we are seeing same parameters. So maybe tomorrow morning we might have a downtime, which means that you are predicting that there could be a downtime or an incident of the server or application going down in 24 hours from now. But you already have a solution. If it's automated, the way you would have set that up is whenever it reaches this threshold, the script should automatically run and fix that issue. So you break things to understand. You break things deliberately to understand. When it breaks, how does it break? How do you fix them? Right? When it breaks, how does your system behave? You need to understand all of that. So chaos engineering was a concept floated then by Netflix to understand when something went down, what are the characteristics of that going down? What did it impact? What services did it impact? How did the system behave when that went down? They jotted down everything, created solutions around it, automated it, and they are running a very successful business now today, right? And if in fact I worked with one of these senior guys in Netflix about 5 years back for a minuscule project, and during one of those projects, one of the Netflix guys gave me the story how they did it. Right, so 10, 12 years back, they had a board meeting, where the founder of Netflix came back and addressed all the directors and told them, hey, you know what? I want to be the best OTT platform in the world in the next 2-3 years. So please give me an idea of what do I need to do. So they brainstormed for a day. Then one gentleman finally got up and said that, oh, I have an idea. Then he said, okay, I want to form 3 teams. One team is called the breaking team, a second team that's called the observing team, a third team called the solutioning team. Now, all 3 teams will be active. The job of the breaking team is to go connect to the internet, connect to our cloud, and bring down servers at will, random, shut down applications, crash database, bring down servers, do all of that, which is they're basically creating failures. That's what is called breaking team. Then while all of that has happened, they were calling out saying that which server they're bringing down, which application they're bringing down. So the observing team kept on jotting it down, saying that, oh, server number 17, application A was brought down at 11:03. They jotted down. And then the moment it got done, the observing team went into the system to understand when server number 13 on rack number 7 was attempted to be brought down, application 13 went down first. So then they went back and looked at what is the impact of this application going down? What all services did it impact? They identified all of those. Then they figured out a solution for that application. So in the event this application goes down, can I run a alternate instance elsewhere so that the traffic can just be diverted? Should be just a split of a second kind of changeover. So that they successfully tested that and were able to demonstrate that this indeed works, which means that you have, in fact, one of the most popular tools in the market is called Gremlin, Gremlin, Gremlin. One of the most popular tools that is used to break things in real time to see how do they behave when they break, how do they restore themselves back to normalcy after breaking, what is required to support it. So all of that put together is chaos. Chaos engineering is more around testing the fault tolerance of application. The most famous example is the Simian Army from Netflix. So Netflix had 2 tools. One is called the Chaos Monkey. The other one is called the Simian Army. All of these concepts originated in Netflix. So breaking components to discover the weakness, designing resilient fault tolerant system. That's what Netflix did. Providing confidence in recovery mechanism, which means that for the team that is maintaining it, they become confident now, saying that when a breakage happens, they can actually fix it. Or there are automations that can go back and fix those breakages. This became a very popular concept. Tools were invented. We can quote so many examples. I have done a few consulting assignments myself where we have tried breaking systems and applications for clients, and then showed them what is the impact of those failures. And then we mapped them back to when those failures happen, how did it impact the business? Why is it important for them to go address that? We help them create a business case back to the business. to make them understand that if these kind of breaks happen, how does it impact the business? And then the business gave them the buy-in to go back and fix those or automate solutions for those. All of that happened. Now, the most important thing that to be learned in chaos engineering or building resiliency is that you should never do this on your production environment. Remember, when Netflix did, they recreated their production environment. They diverted part of the production traffic to the recreated environment. So it cannot be done on production. In fact, the customer that I have worked with, some of them did ask me if we can work on their development or the testing environment, the lower environments. My answer was no, I don't want to work on a customer environment, primarily because you don't know what data they have. When was it last backed up? So the point is, why would you want to touch something on which you have no control? So my request to my customers have always been, can I put up one more instance of the cloud, recreate your prod there? I will back up your application, restore it there, backup data, restore it there, then get some test traffic to work on the server, then start breaking things, identifying all of that was being done on a server that we recreated. So the choice is here whether you want to work on the lower environment, theoretically, practically, professionally, you're allowed to work on the lower environments, which most companies do. But as a individually, as a person, I have always felt uncomfortable working on even their lower environment. So I have chosen always to go back and provision a new server on the cloud, of course, with the permission of the customer. And then that instance will get killed the moment the experimentation is done. Right? So that's how you'll conduct chaos in the experiments. It's so important to do this. I'll tell you the importance will be felt when large downtimes happen. And there are a lot of companies, enterprises, including government agencies, that are willing to get this done. But the point is, they want somebody to talk to them before, somebody to convince them that this will not harm their servers, this will not harm their applications, it will not bring them down. On the contrary, it will build the confidence on their applications and infrastructure if we can get this done maybe once in 6 months, once in 9 months, once a year, depending upon the time frame. That's chaos engineering, all of it for you. Implementing SRE in organization. It's the picture on the right looks very, very complex, guys. Don't worry. It's not as complex as this. SRE, there are multiple ways of implementing SRE in your organization. Right? And one of them is establishing something called an SRE COE, a Center of Excellence. Right? SRE sits right at the bottom here. Just look at this bottom, the bottommost bar that you see here. That's called your SRE product and platform team. What they then do, this is a banking environment. What they do is they place one of their SRE in each of the product, right? Core banking is a product, they have one SRE there. Payments is one product, there they have one SRE. Customers and finance and accounting, they've got one SRE sitting common. So for each of these products, right on top, you'll have one value stream owner. Right, look at this. Core banking payment system, this one, the first, they have a value stream owner. So any change that you want to do in this product, this value stream owner has to initiate that and sign off. So every time he wants to make a change, he will call this SRE, who's part of the core banking team, and tell him, I want to make this change. What should I do? This SRE will come back to the SRE COE, which is his parent organization, consult with them, go back with a solution to him, put it up for approval. Once he approves, it goes back to the finance for cost approval or buying approval. Once all of that is done, everything gets delivered. This SRE, along with the operations team, which sits here, infrastructure and platform management services and operations, together, along with this SRE, they implement all of the changes that they want in the platform that they have here. So look at the different layers. This has got an operations layer. This has got an infrastructure and platform management services. They've got a data platform integration layer. This has got a compliance platform, using which you can make sure that you're compliant with the regulatory bodies and all of that. So everything that they want to do will be done with permissions, approvals, OKs from the value stream owner and from the SRE COE. So when you want to implement a SRE in your organization, first thing you need to do is align incentives with stability, delivery speed. So you have to go back and make sure it is top-down driven. Implementing SRE is to be done top-down driven. It basically means that you should start with the head of the company, a CEO, a managing director, a senior director who drives. The culture has to be brought into the organization. People must be willing to accept the way things will work in the new SRE implemented organization. That's the first one. And then to implement it, you have to promise some goodies to the people, saying that, oh, if you start working the new way, you'll get some incentives. What are the incentives? Your work will get done faster. You'll be able to do more releases. 5 extra releases this year, guys. We will give you 1% extra on your salary. So give them those kind of incentives that will motivate the team to adopt SRE faster. Begin with a small team of servers. Don't go big bang change. Work with smaller teams. Try implementing SRE for them. And then see how it progresses. Depending upon how it gets accepted, then start spreading it across the organization. Implement strong metrics in logging. Now, let's say when you start with a small team, when you implement, you have to implement it along with strong metrics and logging. You should know what is happening. That you can get to know that from the log files. And you should also be in a position to measure. Whenever you implement something, make sure that you're able to measure it, because if you don't measure, you will not know how to improve. You will not know what is the current status. You will not know how to move to the next status. So it's so important for you to implement along with strong metrics and logging. Then developing a blameless incident culture. We just saw that, right? We just said blameless post-mortem. Whenever an incident happens, when you're performing a root cause analysis, you don't want people to point fingers at somebody saying that you caused the issue. The point is whether he or she caused the issue or not. The point is, how do you get out of the incident first? What kind of learning do you pick up from the incident? How did you fix that so that this incident happened again? We will have the same solution. And finally, can this solution be automated? Right? If you can automate it, you can say the next time this incident occurs, automatically run the solution. It'll save a lot of time, heartburn, downtime for the client. It'll benefit everybody in terms of doing that. So incentivize people to adopt and practice, implement and practice SRE within the organization. Implement them with strong metrics and logging. Finally, develop a blameless incident culture. Measuring success, perhaps the last slide. Improvement in incident response time. So how do you measure that after implementing SRE that my organization has benefited? What kind of metrics do you have? Some of them are, there are about 3 that they've given, big ones, which is improvement in incident response time. How quickly have you been able to respond to an incident? How quickly have you been able to fix an incident? Reduction in toil. Reduction in manual work that gets done. Better services stability, which is the moment you have identified the right SLIs. Remember, I was telling you, SLI is nothing but anything that you monitor becomes an SLI. For instance, if you're monitoring availability, availability is an SLI. Availability at, let's say, the time now is 3:15 Malaysia time, right? Availability at 3:15 is 99.97%. At 3:17, it will become 99.98 or 99.48, right? So the reading of the SLI can vary over a period of time. So any reading that you see at a given point in time, it's a point in time value. Generally, SLI is measured as a ratio of 2 numbers. Total number of events divided by total number of good events. All of that you'll learn as part of the SRE Foundation course, where we'll tell you how to measure SLI, how do you calculate SLI, all of that. But the point is, to do that, you must identify the right things to monitor, right? I always I worked a lot in healthcare, fintech, manufacturing, and retail. Of late, I've also done a lot of work in the oil and gas and refinery, where I do a lot of data engineering work, right? So one of my most favorite areas, pick up healthcare example, right? A patient goes for a heart attack. One of the primary areas that you'll monitor for the patient when he's admitted in the intensive care unit is his heart, is his blood pressure. Those are critical factors that you need to monitor, because if anything ambiguous happens in those areas, the patient might die. But rather than monitoring that, if you start monitoring his kidney, his kneecaps, his foot to toe, his eyes, you will never get to know the right metric or right measurement. So it's so important that you identify what are those important things that you need to monitor, and then everything that you monitor should ideally have an SLO. It should have a inbuilt SLO that comes with it. If it does not have, guys, there are ways to calculate SLOs. And as and when we do the SRE training, we learn how to create SLOs, and how do you go back and compare them? How do you go back and use them to measure against SLI values to see if you're good or bad? And how do you convert your SLO to SLA? All of that will be part of the training. But the emphasis here is on identifying the right things to monitor so that you get the right readings and right sense from the service. Reduction in toil. Automation is the core concept of SRE. Without automation, SRE does not exist, right? So what they do is anything that is manual. In fact, Google is where SRE was born. So Google propagates this theory that SREs should spend not more than 50% of the time in ticketed activities. And the remaining 50% of the time, they must be spending on non-ticketed activities, which could contribute to improving your system's ability to perform. Which means, can I pick on manual work and automate it? Can I make my systems more efficient? Can I make my backups faster? Can I reduce the latency of my network? Look at improvement areas that SREs can work on. So that is the only way by which you can reduce toil, improve automation, and then make your systems more robust, resilient, and delivery ready. And lastly, better service stability, which is SLI and SLO. The SLI, SLO, where now every time you don't want to go in and look at the system and calculate and see whether your systems are doing well or not. What you do always is you look at your SLI reading, go back and compare to the SLO reading. That will tell you whether you're doing good or not. For instance, you're monitoring your body temperature. The standard temperature that medical fraternity says for human body, it might differ across different continents, but Asia Pac, I'm sure it must be in the range of 98 to 98.5. Right? When you monitor your temperature, when it is 98.4, it is normal because your threshold is 98.5. You're within the threshold. Now, 2 hours later, you monitor temperature, it is showing as 100. It is beyond 98.5. It is beyond the normal acceptable value. That tells you that something is wrong. You must take some action. What action? You probably swallow a pill, probably take a paracetamol to make sure that your body temperature becomes normal. So you will initiate certain actions when you see that the threshold that you have set for SLI has been breached. Unless and until you know that, so if you don't know, let's say if you're not measuring, you will not know that. If you do not know, you cannot improve. Your temperature will move from 100 to 101, maybe, right? It'll keep getting worse. So it's so important for us to measure so that we can always continue to improve. One of the best things that can happen is constantly measure, which you don't have to do. Now the system itself does. Look at all those monitoring or observability tools like Prometheus, Splunk, Zabbix, Nagios, Dynatrace, New Relic, ELK, Datadog. Name them. There are dozens of tools in the market that you will find. So all of them, any tool that you use will obviously tell you what are the SLI values, what are the threshold they have set, and what's your current reading? Has it exceeded your threshold or not? Has it exceeded SLO or not? You will get to know it instantly. And if you enable traces, the moment you know that you're not meeting, you're exceeding your SLO target, you'll automatically look at the traces, find out what's going wrong, immediately fix that so that you bring it back, which means that you're not having a downtime, basically, but you're not meeting your SLOs. That is how you constantly look at improving your system over a period of time. So that, gentlemen, I think brings us to the penultimate slide, which is Q&A and wrap up. I will pause here for some time just to look at the crowd and ask them if any of you have got any questions that I can answer. And feel free, in case you don't have questions now, you have questions later on, you can always reach out to Gigi or her colleagues, send them over an email. We will be happy to help you with answers for your question. Any questions now for me, guys, that I can answer now in this forum?
You can feel free to ask questions. Thank you.